pathway, the main problem that we have is actually overtopping. So overtopping over our seawall gives erosion on the backside of that seawall and gives chances of a breach in that seawall, and then we have floods. So actually it's really a simplified system that we use, but it's some practical way of us dealing with our problems. So an overtopping means flooding. Flooding means then at the receptor side a lot of things. So we have property damage, we have problems with our important structures and so on and so on. So this is more or less all the things already said last time. What can we do? I will explain more and more in the next slides. So what can we do? We can make flood defenses to protect ourselves against those storms. And of course, we can also do it more like property level, so we don't really build our flood defenses, but we will defend the properties itself. But we chose to make like a main flood defense. So, which are the drivers for the project in Middelkerke? We look until 2017. Why? Because the lifespan of our project, it will also be 15 years for concrete structures, and that is 15 years that we, because it's an urban area, and after 15 years most of the concrete structures and all the pavement and everything, it has their, it's done after 50 years. You need to renew it anyway. And then directly influenced is the significant wave height, because significant wave height, when you divide it by the water level, it's always a fixed factor, because when your water level is going to raise, the waves, they have less friction with the bottoms, and also your wave height gets higher. So this is like a picture in, not in Middelkerke, but in Blankenberge. So the waves can be quite high during such a storm at the Belgian coast, and also what we see, of course, is a sea level rise. There's a picture of the 2005 of last. So we actually see this one is over the whole world, but they made of 23 measuring points, and you see the sea level going up. Okay, so I don't have to convince you. Actually, I had a nice discussion with the project of Middelkerke. We had a big presentation for the population half a year ago, and then there was a major politician in Belgium, which is very extreme right, and he was really like discussing again like sea level rise, it doesn't exist, and why are you doing this and everything. So that person I had to try to convince, but
was he interested in the evidence?
No. He was just talking and talking and talking, and yeah. Anyway, this is the storm of 2013 to show you what happens at the Belgian coast. It's not really visible, but here would be the Belgian coast. So this is like Belgium, this is the Netherlands. But what happens is, during such a storm, you get really big winds. No, the wind blows from the North Sea down to the south, and you get a lot of water that's being pushed towards the Dutch coast and towards all the coast here, and especially also the Belgian coast. So a lot of water is being pushed between England and Norway and Denmark. Also, you get very big waves, of course. When you have wind, it's not only the water that gets pushed, but it's also a big plain where big waves are generated. So we have a combination of a storm surge, so it's like a big water level that comes really on top of a spring tide, and then you also get big waves. That happens. So these are the pictures of 2013. So that was a major storm that we had. Also everybody else, I assume, around the North Sea. If you see that picture. So again, the numbers: 7.42 meters TAW. And the zero would be our mean low tide. So the lowest water level you more or less get during the past 50 years, that would be like the zero. And we calculate with a significant wave height of more or less 5 meters. And that would be at a water depth of -5 meters. TAW. And then of course that combines with the storm surge, you get a big storm, and then you get problems. Boundary conditions again. So the zero would be the mean spring low tide. The normal spring high tide would be around 4.65. But if you calculate everything in, also with the sea level rise, we get a water level of 74 meters. So almost 3 meters higher than our spring high tide. And then of course during 1,000-year storm. Our return period is 1,000 years in Belgium. Our protection level, and then we get the wave heights on top of it. That we use as boundary condition in our calculations and also used in our analysis. And this is also to show what happens with the wave height during influenced by the sea level rise. So this is 2017. We have HS of 4.82, and in 2030 it already gets 5 meters due to the sea level rise. During a storm, what also happens is erosion of the beach. So this would be like the initial beach level. And in Belgium, we actually do something very stupid. We work against the nature. This area would be above 7 meters of a local reference. And why we do it, that is to protect all the little cabins which are on the beach and beach bars. So during summer, they want to have an exploitation of the beach. They want to put the beach bars also have in the Netherlands, the cabins. They want to be safe for summer storms. So actually, we have to put sand there for them to protect that. But the problem is that's very artificial because we put that's maybe 30, 40 meters wide, and we put that at a very high level. So during a storm, we get cliffs there. So it really are, after a storm, walls of 3 or 4 meters high. Then you have to break that again. And you also see, this is a calculation with X-Beach. It's a model to predict what will happen during a storm with the beach level itself. And you see, a storm is just takes the sands from above, and it really wants to level out the beach. So this would be the natural beach level, and this would be the thing that we do. So actually, we are being stupid, but that's all. Economic reasons and touristic reasons to put the sand there, because otherwise we would need to make a beach like this, but you can already assume the amount of sand that we would need to put there. So that's not feasible. What happened? This is a picture of 2013, and I was very lucky because I was the one taking that picture in a helicopter. It was like a lottery, so 2 persons of our agency could go, and I was one of the lucky people. So after that storm, we made a tour over the helicopter of the whole coast, and we could take, and we had to take photographs to see what happened. So this is actually what happened during the storm. This is, I think, at least 3 or 4 meters, a wall of a lot of sand just eroded. So the sand actually didn't work because it dissipated a lot of wave energy and protected the seawalls. The same picture, but taken from the other side. So it's taken from here. This is actually the same seawall, so you can recognize the pattern of the pavement. And here you see what happens during a storm. Actually, there is a lot of overtopping, so that's why we need to put sand in front of it. And this is actually a point at the Belgian coast that's very eroded. Each 2 years we need to put sand there. I'm still on time, or do I need to speed up? 53, major storm, very known in the Netherlands, also in Belgium. We had some damage. It was much less than in the Netherlands. But to show what happens if we would do nothing and what is the result of overtopping, you have a lot of erosion at the backside of a seawall that erodes, it collapses, it breaches, and then we got floods in the center of Austin. And this is 2013. It's not Middelkerke, it's Blankenberg in Belgium, but I wanted to show you this. This was actually the top of a seawall, of not really a seawall, but it's in a marina, a very low-lying marina, and the water was 30 centimeters below this wall. So we had to put sandbags there more or less already to protect it. Now already we built walls here in that area. So this area is in 4 years' time, we were able to protect that area. It was a project that I was project leader of, so I already finished this. And also the water is also getting more or less half a meter below this area here. And this one we're going to, in the coming 2 years, we will build the last walls also in this area to protect it. At the receptor site, if we would have a breach in the seawall, here is Middelkerke, this whole area would flood. We already calculated the damages of what would happen. So we just assume a certain water level because of a breach. And then we calculate with a sort of a system the damage that would occur to the buildings and also some loss of life. but the numbers are still being reviewed, and I'm not able to share it with you yet. So I hope to. So once I have all the numbers, I will also include it. At the moment of our pilot area in Middelkerke, actually, as of today, it's protected by a very large beach. That beach was calculated with very conservative methods. In the past, it was 5 years ago, our methods were not as refined as they are today. And that's why Middelkerke is actually very good protected. That beach can really lay there for 10 more years without any problem, because we have a really big buffer. But in the last check that we did, we had some problems that the seawall itself, which is more or less here, that we don't, some of them are very old, more than 60 or 70 years old, and we don't know how the outer layer of that dike is, because it's bricks, and bricks tend to fall apart after 50, 60 years. So we now have a lot of problems with that outer layer. So we don't really know how strong it is. So when some wave would slam into it, we don't know if it will hold. But anyway, we are now busy with the project to renew it. And the overtopping at this moment is lower than 1 liter per meter per second, which is our limit. We just say our beaches are overtopping over the seawalls or walls in the port. The overtopping needs to be less than 1 liter per meter per second, and then we assume it's more or less safe. Now, with the pilot that we are going to do, we are going to build 10 meters extra, just a lower laying part that we will build in front of it. So this would be the current seawall would be like this. We build an extra 10 meters in front of it, and it consists of 2 walls, a wall here and a wall there. So the waves come from the beach, they slam into the first wall, what gets over it slams into the second wall, and then the water is returned, and then it meets the third wave that's coming over it. And so it gets damped out, the wave energy. It's a very efficient system, and then there are holes in the first wall, which would be here, so the water can flow out. So the system, we are now testing it in the wave flume for the efficiency, but our initial calculations showed that the overtopping would be limited to 0.66 liter per meter per second, even with a much lower beach and also a much less wide beach. So the beach will be lower, and still the overtopping will also be lower.
And the loads on the first part, won't they be quite high as if it was further in? Is the load lower on the first part than it would be if you just had one wall?
The loads?
Yeah, the weight loads.
The forces.
Structural loads.
I think they will be higher, actually.
Yeah, they're a bit higher.
They're a bit higher. Yeah. Because normally the waves would have to go higher to reach that wall. Yeah. So all this would be like 40% of the pilot area would be this structure. And we did something very innovative for Belgium. We are going to put dunes in front of our seawall. The first time we are going to build dunes like that. But it's very interesting, because those dunes, it's like the project in Katwijk. I don't know if many people are familiar with that project, but it's really the same, because we are also going to put a parking garage there.
Exactly.
Yeah, it's going to be completely the same, and also the view. So this is something from the politicians. They don't want the dune to get too high, so all of the people always have to be able to see over the dune, but they have to be able to see the sea and the water. So for us, the dune must be high, because a bigger dune means more safety. But for the politicians, they say, no, it can't be too high, because otherwise you can't see over it. So that's why, more or less, we find a solution where we have the dune, that it can grow, and it also can lower a little bit of erosion.
Niels, can I do a question in between your talk?
Sure.
Dunes is also a natural process, so they are growing when you do nothing. And so you have to maintain them to be low.
Yes. Yeah. No, but it's actually a very complicated question, because there's a nature law that says once you have dunes, you cannot. They are protected. So you have the dunes are starting to grow naturally, like a little small dune, and then they get bigger and bigger, and you cannot change the plants that are growing on top of it. So you need a sort of exemption from the government that you can really work on it. Yeah. So it's really not that easy to have the system. But they can't get higher, because otherwise you have the risk of a collapse of your parking garage. So it's really a tricky situation.
A parking garage also in it.
Yeah, there's going to be a parking garage like this. The same like in Katwijk, because in Katwijk it's also the same. So they also have the problem that they can't get too high.
Aren't you having the problem that the sand is sliding into the sea? You have the vegetation.
Well, we have the vegetation on top of it, but still during a storm, some sand will erode and it will go to the beach. That we're also aware of. Yeah.
Regarding the time, Niels.
I have 2 more slides.
Okay.
Just a quick one.
They're always asking questions.
How much sand are you expecting to move off that promenade?
By erosion?
No, by wind-blown sand coming across where you've got people walking.
Well, actually, we expect it to be less than what we have. It's very difficult to make a prediction of it, but at the moment they have a lot of problems with the sand on top of the seawall. But we expect it to be less because of the vegetation that will capture the sand during a storm. That's what we expect. And from the erosion side, because of the waves, we now calculate with 10 cubic meters per meter per year. So per meter when you measure over the parallel coast. So that will be 10 cubic meters per year.
I have another question as well. I don't know whether it's the time for, but we had a few weeks ago the presentation of new expectations on sea level rise in the Netherlands. They could be much higher than we expect just now.
Yeah.
And you said, okay, we calculate 42 centimeters in the end of the century, and the heights of this figure are designed for that increase. How sensitive is the solution for uncertainties in the sea level?
Well, actually, this is a very adaptive system because if we see that the sea level rise, it will be higher than what we expected. Then, okay, for the dunes, we just get bigger dunes and we don't care anymore about their size because we need to protect them. Okay. So it will be similar, and also we can make the beach wider. So with putting sand in, we can make more or less make the same boundary conditions at the toe of the dike. So that's what our strategy is.
Yeah, the dunes, that's a very good solution, natural solution. But the former slide with the two stairs protection. How sensitive is that for instance, 1 meter higher sea level rise than you calculated before?
Well, it's always the matter of getting, so we now have a set of boundary conditions, water level and AHS, and significant wave height at the toe of the dike. And that combination of water level and significant wave height, it gives a certain overtopping. But it's highly influenced by the beach in front of the seawall itself, because you can calculate that with wave transformation methods like swash or I don't know, like modeling, numerical models. You can calculate that. So we will have to change the beach then to get the same result in overtopping, overdepthing. So that's
so as well in this concept, the sand is the button you can switch to adapt.
Yeah, that's what we did actually.
Okay.
That's what we did. We played with the level of the beach in front of the seawall to get, because this was more or less fixed, they would 10 meters because it was also the cost price. So this was 10 meters, this was 1 meter, so all the dimensions of the seawall, it was already determined before we started with the project. And that's why we played with the beach level in front of it to get the overtopping that we wanted. So, now, quickly, my last slide, I think.
No questions anymore, this is the last slide.
Sorry. Also, another thing that we have to consider, because of the dunes, we don't anymore have a hard structure at the back of it. So we make a new dune. And the problem is that we get erosion. So we always calculate with the minimum profile because we don't know what the dune will do due to erosion, due to wind. So the dune can get lower than what we want. So we calculate it with this is 7, this is 8, this is 9. So it's 1 meter and 1 meter higher. And then you see you get a lot of erosion in the seawall itself because we look at it as a sandy thing without hard structures. And then you get problems with the foundations of the buildings. So because if this erodes too much, then you get your failure, you large slopes from the buildings, from the foundation, then you can get problems that the foundation of the building it will fail. So that's why we also have to consider that the erosion is not too much in the seawall itself. So this is always something we are considering.